Welcome to Team 3's APS 380 final project video. For this project, our team decided to create a dual-motor planetary gear transmission with all-wheel drive capability. Our objectives for this project were to design and build a dual-motor planetary gear transmission, also known as a DMPGT. Number 2, to design and build an all-wheel drive system. Number 3, to demonstrate the capabilities of a DMPGT in single motor operation mode, dual motor operation mode, and demonstrate dynamic torque while sustaining a set RPM. And the fourth objective was to demonstrate all-wheel drive capabilities in an all-wheel drive mode, front-wheel drive mode, rear-wheel drive mode, and also show active torque vectoring. This is the system architecture of our design. In the middle, we see our power source, which is a 3S LiPo battery that runs at a nominal 11.1 volts. Our controller is an Arduino Mega that is used to control all the motors and servos and take in inputs from our sensors. Looking at our driveline, there are two BLDC motors per gearbox. A higher kV motor is on the sun gear and a lower kV motor is on the ring gear. There are two servos that control the clutch actuators for each side, one for the left wheel and one for the right wheel. There's also another servo motor underneath the gearbox to apply a brake to the ring gear during single motor operation mode. There are also two Hall effect sensors, one per wheel, to detect the RPM of the wheels. Going into a bit more detail into DMPGT systems, we see that by varying the speed difference between motor 1 and motor 2, we're able to achieve variable gear ratios on the carrier output, all while the system's moving. So this is all done without interrupting power delivery to the wheels. For example, in an ICE car, we see that when you shift gears, power delivery is stopped to the wheels momentarily. However, in a DMPGT system, the gear ratio is changed continuously as power is being delivered by varying the speed difference between motor 1 and motor 2. Also, using a DMPGT creates a wider operating efficiency zone compared to a single motor system. At the top of the slide, we can see the internals of our planetary gear system. There's the sun gear, the ring gear, and the carrier gear. And all the way on the right, we can see what the assembly looks like all together. In this next slide, we see the planetary gear system fitted inside of the gearbox housing. The green arrow is pointing to the brake that is applied to the ring gear during sun motor only operation. In this next slide, we see the all-wheel drive clutch system that is used to engage or disengage the wheels from the power. When power is required at a wheel, the pinion on the servo motor pushes the rack forward, which in turn pushes a clutch plate. This clutch plate has a friction surface of sandpaper. When the clutch plate makes contact with the gearbox output plate, the power is transmitted from the gearbox to the wheels. In the following videos, you will see different clutch operating modes.